Hi, welcome to this last lecture in data analytics for the social sciences. Today I want to finish the block on doing text analysis by looking at one of the most common and most popular methods in text analysis, topic models. I will first in a couple of slides explain the basic idea of topic models and how it can apply and what kind of variations exist. Then I will do a slightly more extensive example based on my own research on the Kremlin. And then finally, I will have a few sort of things to say about the course in general, now that we've reached the final lecture, and also the third project. Okay, let's get started. So today I want to talk about topic modeling. And topic modeling is really taking a flight in political science and in text analysis in general. And it's sort of a next step beyond what we discussed last time on ideological scaling. But topic models are not developed in political science. Topic models are developed in machine learning in general and in linguistics. And there are by now quite a few variations and developments and innovations. I'm really just scratching the surface of this area, giving you the basic idea of how topic models are designed, in particular LDA models. But there is quite a bit more, and it's a very quickly developing field. So it is, as this whole third block in the course, we are talking about an unsupervised algorithm. So we are looking at an algorithm where we do not know the correct classification. So we don't have a list of predefined topics that we're after. We are just going to search what these topics, or what these documents might have as topics. So the basic idea here is that for a set of documents, and this can often be thousands or maybe even millions of documents, we try to find out what the topics are that these documents are about and which documents are about which topics. Yeah? So the assumption is that there is a close association between topics and word usage. So if a set of documents use very similar terms, very similar words, we assume that they are on a similar topic. Whereas to other documents, if they have very different topics, very different terms, apologies, then we think that they are on a different topic. So we can see you have to really think back to the clustering we did about 3 weeks ago. We looked at the text data and we tried to divide it in different clusters based on the word usage. And really what we're doing here is something similar. It's a model, a statistical model that we try to estimate, a little bit more like the IRT model we discussed last week, but it is more similar to the cluster analysis. So how can we group the documents, how can we group the terms so that we can separate out topics? And the process we're going to use is called LDA, which stands for latent Dirichlet allocation, but you don't need to worry about that. Now, this is just one of the methods. There's other methods, but this is just to give you an idea. The basic idea of the different topic modeling approaches is the same, but there's all kinds of variations, innovations, etc. And in particular, there's also a lot of innovation now in how we look at this term document matrix. So the model assumes that every topic is related to some words. So if the document is about a certain topic, then particular words will have a high probability of being in the document and other words will have a lower probability of being in the topic. So you can think of a topic as a set of probabilities for each of the terms, how likely that term is to appear in a document if it is on that topic. Yeah? So the definition, so to speak, of a topic is this distribution of probabilities. A document is considered a mix of different topics. So each document mixes a set of different topics and words then appear depending on this mix. If one topic is more prominently present, these words will appear more, and if one topic is less present, these words are appearing less. And finally, then the words are considered random draws from these probabilities based on this mix of topics, and these topics are probability distributions. Yeah? So the model, this is of course not how the text was generated, but the model assumes that the text is generated in this way. The idea is that every word that appears in the text is like a random draw based on a mixture of random probability distributions, and where these probability distributions are the topics over each word. Yeah? So you can think of it as a bag of, it's called the bag of words technique. So we think of these documents really as just a large collection of words. And we try to estimate the topics by assuming that these words are randomly drawn from these topics. Another way of looking at this is a more matrix algebra approach. If you're not familiar with matrix algebra, this might be a little bit confusing, so don't worry about this slide too much. But we have the matrix on the left. You have seen that over the last few labs, and you've looked at this matrix, especially 3 weeks ago when we started doing text analysis. So we have a matrix where every row is a document, every column is a term, and we have this n number of documents by p terms matrix, where each cell tells you how often this this word appears in that document. And the idea with LDA is that we can split this matrix into two matrices, the product between two matrices, one for each document, how probable or how present each topic is, and secondly, a matrix of each topic by each term. Yeah? So in the rows for the first matrix, we get the topic rates for each document. In the rows for the second, we get the probability associated with each term for each topic. Yeah? And so we are trying to decompose the original matrix in these two matrices. And there's many ways that we can do this. So we can come up with many matrices that have this shape. Yeah? So we need to come up with a way of selecting which one we prefer. And LDA selects in the following manner. It finds a way, a distribution where for each document, it represents as few topics as possible. Yeah, so we want a distribution where some documents are closely aligned with some topics and weakly aligned with other topics, and other documents are closely aligned with some other topic and weakly aligned with the first. This is really comparable to how we talked about factor analysis 2 weeks ago, where we try to find factors that closely correlate with some variables and weakly correlate with other variables, so that they help us separate the variables, so that they help us understand what the factors mean. Here, similarly, we want to separate documents on different topics, so we want the biggest separation between documents in terms of these topics. And secondly, similarly, for each topic, we want some words to be strongly associated with these topics and other words to be weakly associated with these topics, so that it really helps us identifying what the topic is about. If you have a few words that are strongly correlated with the topic and many words that are not, then we can look at those few words that are strongly correlated to try to see what the topic is, what it is about. Whereas if every word kind of correlates a little bit with the topic and nothing particularly strongly, then we have no way of identifying what the topic is about. So there are many ways of doing this matrix decomposition, but many of the solutions will have every topic a little bit associated with every document and every word associated a little bit with every topic, and that does not help us to either separate documents by topic or understand what the topics are about. So if we have one that has more variation in terms of how strongly it's associated, more divergence, then we can use the highly correlated words with each topic to identify the topic, and the highly correlated documents with that topic as the topic of that document. Yeah? And this is these 1 and 2 are both preferred, but they are like a trade-off. If you do the first very strongly, then it becomes difficult to satisfy the second, and vice versa. So there's a trade-off here between those two priorities. Now, LDA topic modeling is just one topic model. There are many. There are correlated topic models where there's an assumption that these topics are closely correlated with each other. There are dynamic topic models, which work with the idea that as the topic evolves over time, different words might become associated with the same topic. We might talk about the same topic in different ways in different periods of time. So we need to accommodate that. There are supervised topic models where we have some idea already of certain classification, and we want to run a topic model that aligns with that classification. So it's not entirely unsupervised, as we assume here. There's relational topic models, where we already know something about how different documents are connected to each other and take that into account when we try to come up with the topics. There are ideal points topic models, where we already know something about the ideological position of the author of a document and then take that information into account. And finally, there's collaborative topic models, which is a little bit related to relational topic models. And there's many more, of course. So people have come up with all kinds of variations and implementations of these, but it's just to make you aware that these exist. The basic idea is the same. We try to identify topics in a set of documents without knowing in advance what these topics might be. And we then identify what these topics might be afterwards by looking at which terms closely associate with which topics. Yeah? So we have to afterwards post hoc interpret this output. Yeah? You can identify the meaning of the topic by looking at which terms have a high association with it. Yeah? We can identify the topic of the document by looking which topics are closely associated with it. And we can maybe look at topics over time or by different groups. And we can look at how there are underlying dimensions in this data between, for example, topic usage. So in the next video, I will go to a somewhat longer example to give you an idea of how we look at this data and what we might see. I'll see you in a minute.